Hello guys, I'm going to be explaining inverse functions and how they connect to derivatives in calculus. So basically, an inverse function undoes what a function does. So if a function takes an input and gives an output, the inverse takes that output and gives you back the original input. So this is what a normal function and an inverse function look like. Would you look at that? But yeah, I'll show how to find the derivative of inverse and that's where calculus comes in. So yeah, we have a function f of x, and the inverse of that function is written as f to the negative first x. So I'm going to write out the first example we're going to go over. So f of x is equal to, wrong button. F of x is equal to 3x minus 7. So step 1, we're going to find the inverse. So we're going to write this out as y is equal to 3x minus 7. And then to find the inverse, we're actually going to have to swap x and y. So we're going to go ahead and do that. X is equal to 3y minus 7. Now we're going to solve for y. So I'm just going to move it over here. And y is going to actually equal to x plus 7 over 3. Would you look at that? So now, that means the inverse is equal to x plus 7 over 3. Doesn't look like it, sorry. Yeah, so now we're going to take the derivative of that. So we're going to have a little comma here, shows the derivative. And the derivative of x is 1, it's nothing, cancels out. That gives us 1 over 3. Would you look at that, beautiful. And, and to make sure we got the right inverse, we're actually going to take a look at the original function right over here. And we can see that the derivative is actually going to be equal to 3. Pretty simple, right? And then we know f of x, or 3, is indeed the inverse of 1 over 3. Just like that. Isn't that beautiful? Now we're going to go over a little bit of a harder problem. Yeah. So I'm actually going to write it out as a text box so you can be able to see it better. There you go. A chemical reaction produces heat and has a temperature of NC, and the system is after T minutes modeled by I'm going to write it out. T, I forgot to add the big T. T parentheses little t is equal to 5 ln T plus 2. Outside parentheses plus 3. So step 1, we're going to have to find an inverse. So this is going to become y. Y is equal to 5 ln T plus 2 plus 3. And we're going to move that plus 3 over here to the other side, so it's going to be y minus 3 is equal to 5 ln T, T plus 2. And then we're going to move that 5 over by dividing it out. So it's going to be y minus 3 over 5. It's going to be ln T plus 2. To get rid of this ln, we're going to have to exponentiate e everything. So it's going to be e to the ln T minus 2, e to the y minus 3 over 5. So this is going to cancel out. This is going to be T plus 2. It's going to be equal to T plus 2 is equal to e to the y minus 3 over 5. And then we're going to move that t, or that plus 2 over, so it's going to be t is equal to e to the y minus 3 over 5 plus 2. And that is actually going to be the inverse. That's it. We got it. We did it, guys. Good job. T x, this is the inverse, sorry, is equal to that right here. This inverse tells us how long it takes to reach a certain temperature instead of the temperature at a certain time. So we're going to solve for how long it takes to solve at, or the temperature at 20 minutes. So we're going to plug in t as 20. You have to remember this formula. Sorry, I got to clear it. And this is actually the original formula. We're going to find the derivative really quick. That derivative is actually going to be 5 over t plus 2. So look at that. It's beautiful, isn't it? Yeah. So we're going to plug in the t equals 20 that we talked about earlier. So t equals 20. The formula was t is equal to e to the 20 minus 3 over 5 and then minus 2. And that's e to the 17 over 5. Simple little, hello, doesn't erase. Okay, it's okay. E to the 17 over 5 minus 2. And, like we talked about earlier, the derivative of the previous function, the original function, was 5 over t plus 2. Wait, I wrote it the wrong way earlier. This is the actual derivative, I'm so sorry. But yeah, it was the derivative. This actually comes from taking the derivative of the early function, the 5 ln t plus 2 plus 3. And this was the rate that was given, but it also matches the derivative of the function. And now, since inverse functions reverse each other, that means that the derivatives are reciprocals. So that's going to mean that this is actually dt over dt is equal to t plus 2 over 5. This makes sense because this right here, the d capital T over d little t, is how fast temperature changes over time. But this function, d little t over d big T, is how time changes per unit of temperature. So they're just opposites, which is why we take the reciprocal. Overall, inverse functions help us reverse processes, and in calculus, the derivatives are closely connected through reciprocals. From a biblical perspective, math reflects order and structure in creation. In 1 Corinthians 14:33, it says that God is not a God of disorder, but a God of peace. And we can see that consistency and order in how math works. Even something like inverse functions show how everything follows logical rules, which points to design rather than randomness. Thank you.